Everybody, thank you for joining us today. We have a great session for you. My name is Shane. I run the events over at 10 Capital. We're really excited for today with Sofant. If you have any questions in the audience, go ahead and put those in the chat box. And don't forget to answer the poll at the end of the session. At this point, I'm going to bring up Hall, our CEO, to get things kicked off.
Great. Thanks, Shane. I want to thank everybody for joining us today. We have a great presentation. We're going to kick off with a thought leader first, Marcus Fritz of Advisorio, to talk about the trends in the aerospace satellite industry. There's quite a bit going on in the space right now, and wanted to hear what those trends are. Then we're going to have David Wither talk about Sofant and where they are in the market and how they're progressing with what they're doing. And then we'll wrap up with a presentation from Edward Granville to talk about his experience with Sofant as an investor and what he sees coming up next for them. So with that, let's go ahead and invite Marcus Fritz up, and let's hear from him about what's going on in this space from the current trends. Marcus, thanks for joining us. You're on mute.
Thanks, Hall. Thanks, Shane, for, let's say, having me. Overall, as you said, my background, I'm the owner and working as managing director at Advisorio. My specialty, my background is satellite operations, satellite network operations, in particular their commercial strategy, business development, international business development. I have a background of 25 years in telecommunications and satellite. Used to work in senior management roles in SES, Eutelsat and Arabsat, always building new products in new markets. Since November 2020, I'm working on different mandates around the mobility business development, so mobile SATCOM solutions. In that work, I also came across Sofant and David and his team, primarily because I'm advising some of the downstream business vertical benefiting customers, such as automotive, maritime, some aeronautics. I'm also working as a senior advisor for the European Space Agency on, let's say, the right market solutions that could scale globally. And in that context, I did a market research on ecosystem relevant players. I found Sofant as an antenna and terminal player with quite an interesting and promising approach to market, because what the market actually needs, and I will guide you through a few slides, is an ecosystem that moves from vertical integration to open mass markets, and that moves from, I would say, boutique to overall solutions that can scale globally. And for that, of course, besides the satellite operator solutions, also the respective overall system engineering chain, including hardware, outdoor, indoor units on the terminals. It's pretty important, and even more important for mobility, because for many years that market has not scaled beyond, let's say, a profitable but rather boutique market, primarily because the hardware was quite expensive, and there was lots of vertical integration. So what we're currently trying to do across the industry is creating common standards together with associations like 5GAA and 3GPP, to make sure that those common standards are also globally scalable, and to move then from there into the different business verticals, and allowing business vertical players such as automotive and others the right scalability, because the satellite industry needs, let's say, from a market that was video driven and driven by, yes, mass markets like broadcasting to millions of homes, like you have it in the US, you have it all around Europe, also in Africa and in Asia. That market is, of course, disrupted, is kind of replaced by streaming services. Satellite operators have shifted into more data-centric applications. And of course, the strongest value proposition for a satellite operator is anything that can be connected, either, let's say, rural, remote, or even disconnected. So disconnected, of course, that is maritime or aero, where you can't have any fiber or cable. So we've got a quite unique position. But as I said earlier, that comes often with a small derailer, which is hardware. And hardware in terms of cost, price, weight, power consumption. So as such, the satellite industry has moved into high throughput satellites to improve the business case of the satellites up and running. They need to further deploy and faster deploy new hardware, because also most of the business cases in the satellite industry are no longer 12 or 8-year satellite lifetime, but with different satellite categories and solutions in the sky, from low Earth, medium Earth, and geostationary Earth satellites. You also have different lifetimes attached to that. As such, commercialization needs to happen faster, which needs, I would say, which requires from the satellite operators faster sales, but also from the whole ecosystem, a faster deployment, and of course, better prices, because your business case that you could before refinance over 12 years or 8 years, and you had time for 3 years to be break even, needs to be break even now in year 1 or year 2, because you only have got that 5 years lifetime. So as such, the whole hardware equation is extremely important. On top of that, you saw that, let's say, new disruptors are coming to the market, more or less disrupting the current incumbents, operational players. So Starlink and Kuiper are disrupting, but at the same time also stimulating the market, because they're driving scale quite quickly. And of course, when players like Starlink or Kuiper invest, you also get more investment into innovation. You see people that are reacting, like there's lots of funding also in Europe and in other countries, both to drive innovation, but also to drive sovereignty, not only being depending on one system or two. As such, there's a lot of things going on. And again, when you look at the receiving end on the outdoor unit, you see in my presentation, those antennas are quite bulky at the moment. They get smaller, as you see here on the Jeep or on a little yacht. But still, that is not yet mass market, because even some of those antennas are still quite pricey or do not meet the requirements of the downstream business verticals, be it automotive, maritime industry, or others. And as such, phased array antennas are kind of one of the keys to unlock the new growth in the market for mobile applications, and both for the non-geostationary satellites like Starlink or Kuiper, as well as for geostationary satellites, because everything, let's say, that comes cheaper and faster in terms of hardware unlocks also new business models in the established markets. And when we look at what kind of targets groups are currently active and the market is addressing, again, when you look at, I would say, the good old space industry, it was pretty much hard gov, so meaning military government applications, and some, I would say, very profitable B2B applications or B2B2C applications like cruise ships. And why was that? Because hardware, antenna, big, expensive, no mass market. So only those, I would say, business cases were able to benefit from the current solutions, which were quite pricey. Let's say an average price for an antenna outside on a Humvee or whatever could easily be 100,000 euros or $100,000. Same is true for cruise ships. And that does not necessarily work easily on a fire brigade's car or an ambulance car in terms of business case, and also not in terms of weight or form factor. So as such, with the new innovation coming to the market, and especially also phased array antenna technology like Sofant is providing it, you will see, and you see already, lots of markets being opened and lots of new applications and use cases being available and driven. And as such, that works for new market segments to open them, but that also works back on established market segments to make the solutions cheaper, allow faster upgrades, faster retrofits, or also new installs. Before you had to wait, let's say, for an antenna for the new budget and a new approval by a government authority. Now the antenna can potentially be financed out of existing budgets, because they don't eat up, let's say, the overall budget size that you had, let's say, on your books before. So that also gives much more flexibility and allows, as you see, already Starlink and Kuiper, they address the consumer broadband market in order to meet those price points, both in terms of service as well in terms of hardware. You may have seen that Starlink announced that they are actually now break even and starting earning money with the hardware as well. So you see we've reached a point where we can also open those mass markets. And as such, the market is going to grow from what was bespoke and small quantities, high margins, into lower margins, but let's say high quantities. And as such, it's going to kind of exponentially grow. Just to illustrate that here, before it was pretty much hard government, so military services with 10,000 of units. Now we are getting closer to the 100,000 of units with first responders, connected ships, connected planes, so smaller ones as well. And so what is, let's say, on the roadmap for as a next step, and I will say something more on that, is millions, 100,000 and millions of devices and users. And that's, of course, let's say, enabled also by smaller antennas. And when you unlock a market for something like a connected car, you also unlock the market from a cruise ship or from a container boat to fishery boats. So all those, let's say, miniaturization and mass market enablement and scaling is gonna, let's say, fertilize and drive lots of demand in the market and unlock new business cases that were not thinkable before. Just to give you an example, those are on the left-hand side, you see those kind of antenna that are currently installed by different players, Italian with Inmarsat, which is a mobile satellite operator, or SES with O3b mPOWER, medium Earth orbit satellite solution. Still, those antennas, as I said earlier, can easily cost $150,000 or $80,000 to $200,000, depending on the ship and on the installation. And on top of that, so that means it is pretty much a small market. The antennas such as Sofant are developing, which allow smaller size, easier or lighter weight, low power consumption. That's especially important for connected cars. Imagine you have an electronic vehicle and your, let's say, antenna on the roof is not only too heavy and too big, but also eats up all your battery size and, let's say, limits your range. That's a no-go. So, and on top of that, of course, cost points are coming down, and you see antennas now, let's say, in proper price points. You see lots of, I would say, overpromised price points still from the Chinese market, where they say, oh, and we install it in Zeekr cars and so on. That market is not mature yet because the antennas are still above 10,000 and 12,000 euros. It's a market that's going to come. But let's say we have kind of 3 times of growth waves. We've got the short, immediate business, we've got the midterm business, and we've got the long-term business. And as such, that's also why I feel Sofant is well prepared in that go-to-market. And in my role, I work a little bit as a godfather because, honestly, we're quite selfish from the downstream verticals. We need to have those solutions in order to unlock all those markets because the customers demand it. If you have a connected car, and I mean that even if you only have 5% area not covered, or if you've got a ship and where there is no connectivity and you have no emergency services, that's quite important. So as such, having those solutions available is actually essential for most of the business vertical downstream players. The maritime market, which I also see as a near-term immediate market, because again, it is completely disconnected. You can't fiber, you can't cable it, and only nearshore you can connect it to mobile. So alone there is 33 million boats, and we're currently only addressing government and cruise. So autonomous shipping, merchant shipping was not a business case in the past because, again, antennas are too bulky, too expensive. That's coming next. Offshore energy was, let's say, selective, becoming mass market. And those markets like yachts and fishing boats are the next big mass markets in that area. Then we've got midterm application and midterm solutions. We have almost every government around the world, at least when there's a certain budget, to push sovereign constellations, meaning making sure that the government itself, both for hard gov and light gov, as well as for potentially the enterprises and the downstream business verticals in the market, have a satellite constellation where they can rely on. The European Commission has agreed and just launched a program, the consortium is formed, where there is alone 2.4 billion government subsidies to create a kind of, I would say, European Starlink or European Kuiper solution, which will focus on government services first. Every European country and international companies are eligible to benefit from the program. It will be focused on EU members first, but there's also 700 million extra budget within ESA, within the European Space Agency, that includes all the ESA member countries for pre-development, which means Canada, UK. There are also ESA associated countries and Switzerland. So also that is available to drive innovation. And of course, the idea is not only to drive government, hard and light gov solutions, but to use it as a springboard to also enable mobility downstream solutions for the different verticals, such as automotive, maritime, and so on. And you see it here as a proof how important mobile connectivity and transportation connectivity is. This comes from the initial tender documents that have been sent to the different, let's say, industry partners that were applying as members of the consortium. And you see the term transport management and mobile connectivity pops up here 3 times. That is actually, besides government applications, the second most important requirement for the whole constellation being mentioned here. And as I said, there's already 2.4 billion committed, and the consortium members are going to, let's say, almost commit the same amount of money, either in cash or in contributions in kind, and will invite the different partners as subcontractors. Sofant could also be a subcontractor for one of those solutions to provide the system that's going to be launched 2027 and then operational and full speed globally or in those markets to be covered, Europe and EMEA, by 2030. And this is just an example for Europe. You've got national examples. On top of that, every government in Europe that has a certain government budget. Germany just released a tender for an own German Bundeswehr, so the German army LEO constellation, which comes on top of that. So you've got European initiatives, you've got private market initiatives, you've got the business downstream verticals such as maritime, aeronautics, automotive, that are all driving that market at the moment. So there's lots of growth opportunities once you've got the right product and meet the requirements. That is pretty much, let's say, what I wanted to show, and I'll open for further questions. If you have any question on the specific market requirements or on the different verticals or on the numbers and developments I presented.
So my first question is, there appears to be increasing investment from the private industry in addition to the government. How fast do you see the private industry coming up in investment in these spaces?
Well, you've got a, I would say, misalignment or misbalance between private investment in the US versus private investment in Europe. And that is pretty much because, first, of course, the US market offers better scale and let's say also maybe easier access to finance. But it's also because, I mean, Europe has not made up its mind yet what are the horses to invest and to let's say, to focus on. Take European Space Agency. European Space Agency is funding every antenna development if there's a proposal submitted. But what we don't have yet, and I think that's where IRIS² and others are going to consolidate the market, is, let's say, matchmaking the unicorns into overall solutions. And we had a little dip in terms of private money coming into the market. We've got firm commitments from automotive, of course, maritime and others, that they would be the OPEX customers, meaning paying the bills for the services and for the hardware and so on, what is needed. But we need to have more investment into the space segment, which I think we're currently, other than IRIS² and some specific government solutions, we're still lacking a bit. And the US is much more advanced, and also China with additional government funding. driving joint constellations such as G-Space for Geely cars and so on. You've got local solutions from Korea, and they sometimes also combine connectivity with positioning. So overall, we expect the market in Europe in terms of investments to come back as well. Myself, I'm working currently on a proposal for the European Space Agency with some finance experts, including European Investment Bank and so on, in order, let's say, to pool resources together to drive also the money flow from Europe. And of course, we're also bringing the downstream business verticals together. You may have seen that Porsche has recently invested into ESA Aerospace, the rocket launcher, and into a LEO constellation. So Porsche Digital has invested into a LEO constellation based in Paris called Stellar.tc. So you see also, let's say, private business enterprises at least to have, let's say, single-digit or double-digit millions invested into space companies to unlock new use cases and also to guarantee additional sovereignty.
My next question is, the U.S. government recently invested quite a bit of funding into connecting the rural areas online with using satellite technologies. Do you think other countries are going to follow suit and make the equivalent investment, or is that just a one-off of the U.S.?
No, I mean, we had already similar investments. I mean, what is happening there? When you look at Europe, you usually have the governments picking up the phone, calling their local telcos, meaning Macron calls Orange, or Mrs. Merkel called Deutsche Telekom and so on, to say, how can we avoid digital divide, and how can you please increase your network coverage also for rural developments? Those telcos usually do not have a proper business case to deploy 5G everywhere on the countryside. And you can say between 5 and 20% are usually not properly connected by terrestrial networks, just purely because of the business case, because it doesn't make sense to put masts everywhere. So the addressable market for satellite is between 5 and 20% in markets where you can refinance it. In Africa, it can be up to 40%, but still also the business case of satellite is too expensive there. So as such, you can speak of 40% wide coverages or wide or gaps. But in those emerging markets, other maybe than India or whatever, the market demand is also not given that you can finance the expensive bandwidth on the satellite. So, and those telcos then are investing into hybrid solutions, matching their terrestrial network with the satellite networks. And also, like Deutsche Telekom, Orange, they're also members of that consortium for IRIS² again, and also investing the solutions into that.
Great. My last question
and then,
is,
of course, there's also vouchers. For example, you go to Germany, there are broadband vouchers where you can get your hardware, let's say, potentially subsidized if you live in a rural area. And then for farmers, there's a different connectivity vouchers through the Farmer Association and so on to connect rural farmers to that smart connectivity for smart farming.
Great. My last question is, you mentioned earlier about some countries establishing their own constellations for their own purposes, just like Starlink. Do you think that's something every country is going to adopt ultimately, to have their own constellation, or do you think just a few countries are going to pursue that path?
Look, to have your own constellation, you have quite a budget, okay? And when it's LEO constellations, they're circling around the world, around the globe. So, I mean, in order to have a proper service, you need to have at least 200 satellites. 200 satellites times 40 million or whatever, that's already a price tag not every government will be able to pay. You will have the big countries that are going to justify it through government sovereignty budgets and allow potentially some, let's say, Earth observation and other applications on it that are country specific. You will have IRIS² as a European solution for Europe, Middle East, and you will have people that orchestrate those services for the different downstream verticals. And you will have people that have global roaming agreements where they put Starlink, Kuiper, maybe IRIS², Rivada, whatever constellation is going to make it, I mean, to global mass market, or at least to a pan-European coverage into those solutions.
Very good. Thank you so much for those answers to the questions in that presentation. It's very helpful. Up next is now David Wither of Sofant. David, if you could launch your slides and tell us more about what Sofant is up to these days and how it's progressing.
So yes, my name's David Wither. I'm the CEO of Sofant Technologies. We are based in Edinburgh in Scotland. Today, the company has about 21 employees. Before I joined Sofant, I called an ex-colleague of mine, a guy who happens to be a world-leading expert in the field of RF MEMS. I'll talk a bit more about MEMS in a moment, but that's Sofant's core technology. And I was asking him for some help with my due diligence process. And it was during those conversations with Vic Steele, who's working with us today, that we reached the conclusion that Sofant had a technology which was going to become critically important to the future of wireless communications. So after I joined the business, he was the first guy I hired. So as Marcus indicated in his presentation, mobile satellite connectivity is becoming essential for a growing number of commercial and government applications. Satellite communications terminals with low cost, size, weight, power consumption are absolutely critical to this $20 billion market opportunity. Sofant's SATCOM terminals provide our customers a greater than 10x performance advantage at about half the cost. So you can imagine we're attracting significant attention for this technology. We have a very strong customer pipeline, which includes a contract with Viasat for the development of an aircraft-mounted satellite communications terminal. This is for providing in-flight connectivity. So if you're getting Wi-Fi on a plane, for instance, it'll be coming through a satellite link. And this particular development gives us visibility on $5 million in future revenues. Now, the other reason why this is so significant is if you look at the aircraft market today, that is the single largest market opportunity for satellite communications terminals. So in terms of value, not necessarily volume, but value. And I'll talk a bit more about the market in the coming slides. So the problem that the industry has today, and Marcus alluded to this in his presentation, is that the legacy antennas, the type that are pictured on top of these yachts here, are mechanically steered. So if you would take that dome off, what you see underneath the dome is something that looked like the satellite receiver, the TV antenna that used to mount on the side of your house, but it's mounted on a mechanical arm. So these antennas are very large in size. They're very heavy, bulky. They have to be professionally installed. And because they're mechanical systems, they have reliability issues that have to be addressed. You can make a phased array antenna, the type of antenna that Sofant is developing using legacy semiconductor technology. But the problem with these technologies is that they're extremely power hungry, and that means they generate a lot of heat. So you have to add active cooling systems and large heat sinks. So that is a major challenge. Again, power consumption also impacts the applicability of the technology. So for instance, on a drone, if the amount of power that the antenna consumes directly impacts how long a drone can stay airborne, or an electric car could function, for instance. So Sofant has addressed this solution by developing a passive phased array antenna. At the core of our technology is something called a microelectromechanical system. So I'm speaking to you today over a MEMS microphone. So it is a technology which is very mature from a manufacturability standpoint. However, radio applications for MEMS are still relatively new in the industry, but we use the same manufacturing processes. So that is extremely important part of our strategy. Is the ability to design a supply chain which scales. So this enables us to make the industry's smallest, lightest weight, and lowest power consuming satellite communications terminal. So we are able to reduce the power consumption when compared to legacy semiconductor designs by more than 70%, which means we're generating less heat and we can be passively cooled. This is an enormously important thing for our customers, because even if something as simple as a fan breaks on the antenna, then a cooling fan, for instance, breaks on the antenna, you have to stop using the terminal, because otherwise it will overheat and become and destroy itself effectively. Everything that we have done when we designed this satellite communications terminal It drops into a high volume, low cost, fabless semiconductor supply chain. It is a very flexible architecture, so we have which enables software-defined radio. It enables multi-orbit, multi-beam connectivity. So our terminals work across low Earth orbit, medium Earth orbit, and geostationary satellites. This gives you just an idea of the types of engagements that we're having. The European Space Agency is a huge supporter of this technology. About 18 months ago, the company won a 7.3 million euro grant. It's not a grant, actually, it's a development contract. So it's a milestone-based contract to develop a mobile satellite communications terminal. So we're about 2/3 of the way through that project. It's progressing quite well. I mentioned the contract that we signed with Viasat to develop an aircraft-mounted terminal. That'll initially go into government aircraft, but this exact same satellite communications terminal will also be able to be used on commercial aircraft. SES is a European-based multi-orbit operator. They have a medium Earth orbit and geostationary satellites. So we have a development agreement with them, and I'm in discussions with them currently about developing a terminal for their next generation network. Paradigm is one of many channel partners. So traditionally in the satellite communications market, you sell through what we call VAMs and VARs, value-added manufacturers and value-added resellers. So Paradigm is a VAM VAR, and we are actually engaged with several other VAMs VARs, but they're going to be our launch customer for our first mobile terminal. BAE Systems, very interested in our core technology, our MEMS technology. Slightly different application of RF MEMS, but essentially it's for the development of an antenna, which essentially can connect to autonomous vehicles and is resilient in electronic warfare environments. So again, it's a dual-use technology and addresses both commercial and military and defense applications. So if you want to visualize where Sofant fits, I usually just say we just think of us as connecting planes, boats, and trains, and in the future, autonomous vehicles. Marcus talked a lot earlier about the automotive market and the fact that by the by 27, 28 onto 2020, 30, we'll start to see satellite connectivity directly to cars. This is being driven by autonomy and not Netflix in the backseat for the kids. Of course, once you have the satellite connectivity in a car, you do have the ability to roll out other services on that, but the primary driver for that is autonomous vehicles. And again, we see a whole range of different applications evolving. Again, our satellite terminal connects to all three orbits that you see here. On the left side, you'll see the geostationary, medium Earth orbit, and low Earth orbit satellites. You probably heard a lot about Starlink. Starlink is operating in the low Earth orbit, but there are several operators in geostationary. One today in MEO, but there's a couple of other medium Earth orbit satellites that are being planned to launch. So Sofant is targeting markets where you need multi-orbit capability, but geostationary connectivity is essential. And it's really important to recognize this, where you have mobility and where you have a desire or a need to be connected to a geostationary satellite. Again, this is our market entry strategy. Of course, we can develop LEO-only satellite communications terminals, but the initial terminals that we are developing are designed to be multi-orbit and connected geostationary satellites. So when you develop a low Earth orbit only satellite terminal, let's say like Starlink, it cannot communicate to a geostationary satellite. It just does not have the horsepower to do that. But a terminal which is designed to connect to a geostationary satellite can also connect to a MEO or a LEO. So we're targeting mobile applications where size, weight, power consumption, and cost are very highly valued. And our serviceable obtainable market is in government and commercial aircraft, government, commercial marine. And then there's a kind of a generic catch-all market that's called comms on the move. Again, these are all geostationary capable terminals, so not the consumer market like you see with Starlink today. Because it's geostationary, the terminals have to be larger, and because they're mobile applications, that means these terminals need to be more complex. So even on Starlink, if you look at a mobile application, something that's designed, you'll see that those terminals are much larger, more expensive. And the reason is you need to be able to communicate while moving, and that creates a lot of technical challenges. So these terminals will range anywhere from about $25,000 for a comms on the move up to around $80,000 for an aircraft mounted terminal. Again, geostationary. If we were going to be LEO only, then you can get these terminals down into the below $1,000. The terminals are much, much smaller, therefore much lower power, much lower cost. The most important thing for our customers when they look at a satellite communications terminal vendor is the way we're compared to our competitors is in terms of size, weight, and power. So what we've done is on this slide here showed a cross section of the companies that we're competing against in this market, and all of these terminals have similar specifications. So I think that's really important. We're trying to compare apples to apples as much as possible here. But where we're differentiated is on the technology. So as I said, Sofant uses MEMS. A company like Satisfy and many of their competitors use what we call legacy semiconductor technology. Allspace uses a lens or metamaterial technology, and ThinCom is a legacy mechanically steered antenna. So when you compare Sofant to our competitors in terms of size, weight, and power, you'll see that we have significant advantages in each one of these categories. But in order to convey the magnitude of the competitive advantage that Sofant has, we developed something called a figure of merit. And essentially, we multiply the size times the weight times the power. And if you look at the last row on this chart here, you'll see on this table here, you'll see that Sofant has a greater than 10x advantage on its closest competitor. That is a very difficult hurdle for our competitors to clear. So as we get ready to launch our first commercial product next year in 2024, that's going to be a major competitive challenge, and I think we'll be extremely well positioned in these markets. Just a little bit of background on the team. Sofant is my third startup as CEO. It's my fourth early stage wireless technology business. I set up a European sales operation for a US-based semiconductor company in 1999 in the UK. At that time, we had less than 5 million in sales, and I grew sales to over 100 million. I was working with Vic Steele and Andrew Christie at that time. We all worked for a company called RFMD. And we were supplying the mobile phone industry. So if you look at the key technologists in our business, we came out of the mobile phone industry. So Vic is a leader in the field of RF MEMS. He's an industry expert. Andrew Christie's our VP of Engineering, a long background again in mobile communications. Gary Morton joined us about 2 years ago as our VP of Operations. Again, background in the mobile phone industry. He developed and put into production a very high volume MEMS microphone process for a company called Cirrus Logic. And Blair's our CFO, who's got more than 10 years experience working with early stage tech businesses. But what I would say here, and Marcus touched on this in his presentation, we see in the industry, a lot of our competitors are coming from the satellite industry, or they've come from the defense industry. And they think like legacy satellite guys, or they think like defense guys. So if we look at how our competitors build their satellite communications terminals, you'll see they're very expensive, and they're very difficult to scale in manufacturing. But because this core team has come out of the mobile phone industry, an industry which is hyper competitive, we've designed our terminal from the beginning to be fully automated assembly, a very low cost test procedure. So we really thought deeply about how we manufacture the satellite communications terminal at scale. And that means as volumes go up, our costs drop very, very rapidly. So we believe that we will have an extremely strong competitive position. Our core skills in our team really come from semiconductor design, antenna design, regular RF and wireless semiconductor design, and semiconductor supply chain and module design. So again, very skilled team, which has helped us put together a platform which is highly scalable and low cost. This slide shows you exactly where we are in time. We plan to close a scale-up round at the end of Q1 next year. I'll talk a bit more about the convertible loan opportunity that we're presenting today for potential investors to help us maintain momentum going to our scale-up round. We're currently in conversation with a lead investor, so we do believe that the term sheets and everything will be ready, and we'll be ready to close that in late Q1. So we are about to ship our first satellite communications terminal to Viasat, who's our lead customer. In parallel, we'll start qualifying that antenna, and we expect to begin some commercial sales in the second half of 2024. The first product that we're sending to Viasat is actually our mobile terminal that we've developed under this European Space Agency contract. In parallel, we have already started the development of the aircraft terminal, and we will deliver the first aircraft terminal to Inmarsat in the second half of 2024. We'll begin qualifying and flight testing that antenna. We expect to begin commercial sales sometime in early 25. The last terminal there on this screen is a placeholder for SES. So we're having a conversation with SES about the development of a mobile terminal. So we've got a very good roadmap, which leads to commercial revenues. And as I said, commercial revenues we expect to begin in the second half of 2024. This financial forecast gives you an idea of how we expect the business to evolve over time. We have a March fiscal year end. We are currently generating revenues, but these are non-recurring engineering revenues and contract revenues from the European Space Agency contract. As I said earlier, we expect to start to begin to generate commercial revenues in the second half of 2024, and then we expect sales to grow quite strongly. By the time we get into 2029, we expect to be on about $100 million run rate in revenues and growing quite rapidly. So what we have for an investment opportunity for the folks in the 10 Capital Network is it's a limited investment opportunity. It's a convertible loan. So some of the high-level details of this loan is a valuation cap, although it is to be determined. I just want to give you an indication of the post-money valuation on our last funding round was £35 million. That was an internal round that was closed in August of this year. So that gives you a relatively recent, probably a ballpark idea of where the valuation cap would be. So a discount on the scale-up funding round share price of 20% and an attractive interest rate of 8%. So our fundraising target is to raise up to £750,000. Again, this is to enable us to maintain our development momentum into the Series A. Our closing date, we'll have this investment window open until the 19th of January. So it is a limited offer, and it's a unique chance for investors, early investors, to benefit from favorable terms ahead of our scale-up round, which we expect to close in February, March of next year. So just in summary, Sofant is a compelling equity story. Sofant is enabling a $20 billion industry, which is transitioning towards mobility. We have a critical technology for SATCOM operators as they expand their capabilities in the service offerings. And we're raising the scale-up funding to execute our go-to-market strategy and begin commercial revenues for the business. So that is the end of my presentation. I'm happy to take any questions.
So the first question is about your core IP. What patents or trade secrets do you have that actually provide a moat around the business? What prevents others from copying what you're doing?
Yeah, so Hall, there's a couple things. First, we have 21 granted patents in various jurisdictions around the world. We have 6 additional patents that are in process. But I would say probably the biggest moat that Sofant has is its RF MEMS technology. I mentioned that earlier. That is essentially a custom semiconductor process technology that we have developed over several years. MEMS are notoriously difficult process technology to develop. You need access to a foundry, a lot of money, a lot of patience, and some very highly skilled people to do this. So even if you were to try to start tomorrow with an unlimited budget and access to a dedicated foundry, it would take you at least, I think, 3 to potentially 4 years to get a competitive MEMS process into the market. So I think we have a very significant competitive advantage and a moat around the business.
The second question is, there's a shift into the use of software-defined radio techniques and platforms. How does your technology enhance or enable that?
Yeah. So you dropped out there a bit in the middle, but I mean, software-defined radio, I think what we see is a trend towards software-defined radio in the satellite industry, really on both ends of the link, in the satellite and as well as the ground terminals. We have designed our technology, specifically our terminal technology, to enable software definition. There are limits to what you can do with physical hardware, but we have a very flexible digital hardware. So the modem will determine what software is capable, what software you're running on the modem can alter the types of waveforms that you use, the types of communication standards that you use. So our technology, our terminal has been designed to be quite flexible in that regard. One of the other things when people talk about software-defined radio, the devil is in the details there. The radio hardware really is specifically designed to work on specific frequency bands. It's very difficult to change the frequency over which your antennas operate, but one of the most effective ways to do that is using RF MEMS. So if you go back where RF MEMS were initially used and where we are using them in some applications, I mentioned a defense company earlier, which is interested in this type of application. MEMS are very effective at tuning radio antennas over large frequency bands. So for those that remember back in the day, the old knob on the car where you used to tune your radio, essentially you had a large antenna, and when you were turning that knob, you were essentially varying the capacitance on that antenna, and it would tune it across a large frequency band. So essentially that's what we do with our MEMS devices. They are tiny capacitors, and we can use those to tune the antenna across a large frequency band.
Great. The last question is commercial aerospace requirements. Where do you see those going in the next 10 years? Are they staying the same, increasing, and by how much are they increasing?
Well, I think what we see, Hall, is a need for multi-orbit capability. That's one thing. So that is a clear driver in the market, something that a terminal which it can switch between orbits, and it can switch very quickly. This is something that phased array antennas do very, very well. I think one of the other big things that we see evolving in the market, and again, which is enabled by smaller, lighter weight, lower power terminals, is that you'll see high bandwidth connectivity going into a broader range of aircraft. So today it's only on large, maybe large single aisle or dual aisle commercial aircraft, but now we're starting to see this technology. There's a huge push to try to get this technology into a regional aircraft and even into private business jets. There are services available today for those markets, but they are much lower bandwidth services. So it's not something that could service 30 or 40 clients on a plane. It's something that you could provide a limited amount of bandwidth for maybe 1 or 2 users on the plane, but not really good for streaming videos and things like that. So we do see essentially a proliferation of broadband connectivity across a wider range of airframes. and including drones. I mean, I think that's the biggest, probably the biggest potential opportunity for this technology in the intermediate term is its adaptation in drones and things like eVTOLs, or vertical takeoff and landing, flying taxis, if you will.
Very good. Thank you, David. We also have with us Edward Granville, an investor in Sofant. Edward, if you could join us in the conversation and tell us more about your background and your participation with Sofant.
Good afternoon, good evening, everyone. Thanks all. My background, I'm an entrepreneur and technologist. I'm an electronic design engineer by training. I have been working in the industry for roughly 30 years. And I have spent my time developing and taking early stage technology developments through to the design investigation phase through to high volume production. Like many of the others in the execution team at Sofant, my experience is in ultra high volume consumer electronics. So all of my background, has been focused on looking for and designing for things that fundamentally need to be produced, in hundreds of millions of units. I've worked in a number of different businesses, both from startups, including my own business that we ended up selling very successfully to Maxim Integrated Products in the US. I've spent more recently my time, I concentrate on a very small number of businesses, typically 2 or 3, develop long-term relationships with them. I look for, typically invest in those businesses, and I'm looking for opportunities that leverage my experience in building teams, highly skilled teams capable of making that transition from science project to high volume successful businesses. My interest in Sofant and indeed with the other businesses that I work with, it typically takes 5 to 7 years to make that kind of transition from the point that you start something that genuinely is groundbreaking or innovative. That's a long time, and it's difficult when you start out at the beginning of that as an investor. You've got to be very careful about what you look for. The things that attracted me in particular to Sofant is you're really looking for projects that have a convergence of a number of aspects. So you're looking for technology where there is a fundamental step change that's required. It's something that can be disruptive, that allows new entrants into the marketplace. You're looking for something that's supported by convergence, preferably of standards, and you're looking for a team that's capable of making that transition. I first came across Sofant in 2016. That was the year that David Wither joined the business. Initially, when I looked at the business, it had a very interesting underlying technology. So they were developing the MEMS process that the phased array antenna is built around. It was very early stage. There was a lot of work that was required to be done. And initially, I didn't feel that they had the personnel capable of making that transition. I was introduced to David, who was being brought on as the CEO at that point. And we talked at length about what the requirements were, what a successful team looks like. And cut long story short, we had very similar views on that. I invested very shortly afterwards. I think we closed the first investment round that I was involved in February 2017. And I've been working with them very closely since, along that path. Specifically on the technology side, the things that attracted me, if you go back to 2014 and 2015, the 3GPP, which is the international standards body that defines 5G, 6G communication standards, they were releasing their standards, and for the very first time in mobile comm standards, they were defining non-terrestrial networks as being an integral part of those standards. So, pre pre-5G, a network standard is basically around about a series of towers, communication frequencies, and protocols. And when you move to 5G and 6G, it's actually a collection of standards because as you go up in the transmission frequencies, so you go up from 1 gigahertz at 2G and then up to currently 5G operates typically around the globe at up to about 5 gigahertz. The transmission characteristics, physical transmission characteristics, get worse and worse. And when you get up to the frequencies that are used for communicating with satellites, Starlink uses 15 gigahertz, that's the Ku band. Kuiper uses up to 30 gigahertz, which is the Ka band. The transmission characteristics of these waves through the atmosphere is terrible. They don't transmit through buildings, even on a foggy, rainy day, of which we have quite a few in Scotland. They all of a sudden my mobile phone connection gets worse and worse. So that is fundamentally around about the same time. There were lots of white papers being produced and conversation pieces being put out by the standards body to say what are the challenges for these types of non-terrestrial networks and terrestrial equivalents and working at those frequencies. And they all identified phased array antennas as being a key requirement. And the reason for that is because silicon, which is how we would have traditionally implemented a phased array antenna, the switching frequency that silicon's capable of tops out at tens and then hundreds of megahertz. You can get ever decreasing performance up at a few tens of gigahertz, but you have to throw a lot of power at it. And that's what we see. From my perspective, as a technologist, there's a fundamental opening for an opportunity. The opportunity is to use a passive phased array, which is something that uses passive components. So a resistor or a capacitor is passive, whereas a transistor is active, and you've got to put power into it to get something out of it. What Sofant has is a passive phased array technology built using a MEMS process. That was a key, for me, a breakthrough step, applying MEMS process. There's another aspect of convergence that's critical here, which is that when you're up at 15 gigahertz, the wavelength of an RF is about 7 or 8 millimeters. Well, when something's 7 or 8 millimeters, you can put it on a microchip. You can put it on a piece of silicon. You can use silicon manufacturing technology. When you're down at hundreds of megahertz or a gigahertz, you've got to have a chip the size of a dinner plate. That's ridiculously expensive, so it just doesn't work. The economics just don't work. It's a convergence of the physical realities. There's a convergence of the transmission properties. There's a convergence that says that the incumbents are going to really struggle to produce something that is cost effective and power efficient. And the cherry on the cake from my side is that when you're not power efficient, you generate heat. A bit like when you're over exercising, you generate more heat than you can dissipate, and you can't cool down, and you have a heat stroke. Well, chips do exactly the same thing. When they get close to their performance limits, you have to put more power in, and you've got to get that heat off. And you can't with a traditional architecture at the kind of frequencies that we're talking about. So that really, for me, is a convergence that says there's going to be a disruptive solution. And the disruptive solution is you use traditional silicon technology, but you oversize it and make it much bigger than it needs to be, and running at maybe just 30 or 40% of efficiency. That's one solution, but that's never going to be the market-winning solution. The other alternative is to come up with another active phased array technology. So you might use a metamaterial, and that's what some of the competition has done. But if you use a metamaterial, you've got to develop a manufacturing capability that can produce it at volume. Now, you're never, ever going to compete with the 50 years of microchip technology, where literally trillions of dollars of commercial money has gone into optimizing that process. And that was really, for me, the last piece of the jigsaw that may be interested in Sofant. They're using a MEMS process technology that's interested in designing structures that can capture millimeter wave wavelength radio waves. So they're not using sub 10 nanometer cutting edge silicon technologies. they're using stuff that's been around for years and is fundamentally cheap. You can buy a 8-inch wafer for, $400. When you're working at 90 nanometers or 180 nanometers, and that's what MEMS processors are built on. They're just not building silicon chips. They're building micro machine, electromechanical machines. So it's basically a variable diaphragm. It's as David alluded to before, it's very specialized, which makes it difficult to do. But the underlying manufacturing, we can go to, to Silex in Scandinavia. We can go to a fab in the US. The machines are the same. The chemicals are the same. The underlying silicon's the same. You're just building a different structure. So Sofant has a technology that's groundbreaking. It's well defended. It's very difficult to replicate in a short period of time. And when you're placing a bet in 2016, that's the kind of bet you want to place. What we've seen and what Marcus has been very good at articulating is the other thing you need when you're starting up a business and you're making a long-term development commitment, you need the things you don't control to move towards you. And that's what we've seen. We've seen that accelerate, especially in the last 18 months to 2 years, where we've seen an awful lot of onshoring, pulling back of manufacturing capability back into the US, back into Europe, driven by security concerns that are all driven by comms-related issues. And underlying all of that is this need for phased array antennas, and Sofant's technology in that enables them to produce passive phased arrays. They're passive. They don't generate heat. They don't use power. They just use the energy in the radio wave. And that is really the kind of solution that is going to win out. For me, it's a very, very exciting technology. The key part for whether or not I think it's an investable opportunity is that they've, as David has already said, it has been designed from the ground up to be manufactured at volume by a team who have spent their entire careers focused on very high volume manufacturing sectors of the electronics industry. And that's very different from coming at it from somebody whose background is in space, where you've got 10 layers of redundancy, and you can afford to put that kind of cost into your product, but you can't in a high volume product. It's inherently on a very well established cost down curve. The beauty of putting anything on a piece of silicon using existing packaging, test, and assembly and manufacturing process technologies is that you get a fantastic cost down curve.
Right.
And that puts us, from my side, makes it a very attractive investment proposition.
Very good. Well, thank you so much, Edward, for your presentation there and your discussion about Sofant. David, thank you for your presentation on the Sofant opportunity that is there. And Marcus, I want to thank you for joining us today for the Thought Leaders section, showing what's going on in the satellite space communications. I want to thank you guys for joining us today. We're at the end of our time. We'll reach out to the followers to see who is interested to learn more and get back in touch with you. With that, we'll go ahead and close it out for today, and we'll see you next time.
Thanks all.
Thanks.
Thanks, Shane.